So how can we write an equation for a circle if we only see the circle in the coordinate plane and have no numbers given? Well, first we need to find its center. And one way to find the center, if we can't just eyeball it, is make sure that you look for a point where you can trace the longest distance through the circle, and look for another point where you can trace the longest distance again. And where those two lines, which are both diameters, meet, that will be your center. So let's just remember what our equation is supposed to look like. We got x minus h squared plus y minus k squared is equal to r squared. And we know that our center has to be at a point with the coordinates h and k. So what are the coordinates of the center of our circle we see here? We go 2 steps to the right, and we don't have to go up or down at all. So the coordinates are 2 and 0. And looking at our circle, what is the radius? If we go from the center to any point on the circle, we have to go 1, 2, 3 steps. Doesn't matter if we go here or here or here or any other point. So our radius r is equal to 3 units. Okay, we got everything we need, and we can write our equation now. So the equation is x minus 2 squared plus y minus nothing squared is equal to 3 squared. And let's write this again. X minus 2 squared plus y squared is equal to 9. There is the equation of your circle. This next one is very interesting. Given the center -2, 1 and a radius of 5 of a given circle, determine if the point 2, 4 lies on that circle. Aha! So first we have to write the equation of our circle, and let's just remember x minus h squared plus y minus k squared is equal to r squared. So that means this circle has the equation x minus -2, x plus 2 is what that means, squared, plus y minus 1 squared is equal to 5 squared, 25. That is the equation of this circle. And let's remember, this equation has to be true for any point that's on that circle. So the x and y coordinates of any point that's on that circle have to be able to be filled in here, and then as we evaluate this equation, it has to be a true statement. Well, then let's try it out. If it actually works for the coordinates of this point we have right here, plug in 2 for our x coordinate and 4 for our y coordinate, and see what we get. 2 plus 2 is 4, so we got 4 squared plus 4 minus 1 is 3. That's 3 squared, and that's supposed to be 25. 4 squared is 16, plus 3 squared is 9, and that's supposed to be equal to 25. And guess what? 16 plus 9 is equal to 25. Check. So yes, this point with the coordinates 2 and 4 does lie on the circle. Excellent work, you guys. In our next example, we're supposed to write the equation of the circle that passes through the given point and whose center is the origin. We have been given a point with the coordinates -2 and 3 that's on the circle, so 2 to the left and 3 up. And we are also being told that the center is the origin. And as we know, the origin has the coordinates 0, 0, and that's here. So in order to be able to write the equation for our circle, we need the radius. The radius is right here, and we need to know what the length of the radius is. So we are going to use our equation to find r squared. R squared is equal to the x-coordinate of our point, -2, minus the x-coordinate of the center, 0, all squared, plus the y-coordinate of our point, minus the y-coordinate of our center, and squared again. And now let's find out what that is. R squared is equal to -2 squared plus 3 squared, which is the same as 4 plus 9. So r squared is equal to 13. R squared is really all we need for the equation of our circle, but since here they asked us for the radius as well, let's just put it down. If r squared is 13, then r is the square root of that, so the square root of 13. The equation of our line then is x, and nothing being subtracted from it, squared, plus y, and again, nothing being subtracted from our y, is equal to r squared, and that's 13. Here's our equation, and we found it using the equation of the circle, which is based essentially on the distance formula. Remember, we talked about that in the previous part of this tutorial. But mind you, if you have this here in the coordinate plane, if you had just counted it out and used the Pythagorean theorem, that works just as well. Going 2 steps to the right and 3 steps up, squaring 2 and squaring 3, we get 4 plus 9 is equal to 13 to find our r squared. Both of these work perfectly fine. With our radius now here, we know that our circle has to look something like this, but we were not supposed to draw it anyway. That's just to make it more visual. All right, then let's move on to our last example. Write the equation of the circle given two endpoints of a diameter. So here we are not given the radius, we are not even given the length of our diameter, we're just given two endpoints. But we do know that our diameter goes through the center, right? So we're going to use those endpoints to find the midpoint of our diameter, which is the center of our circle. Midpoint, ring a bell? Okay, so here are 2 points, -1 and 5 is one of them, and the other one is -5, 1, 2, 3, 4, 5, -3, 1, 2, 3. These are our points, and between these 2 points we have our diameter. Now, maybe we're going to be able to eyeball where that center is, but just to be safe, let's find the midpoint of our 2 points. So we're supposed to write our equation in standard form. X minus h squared plus y minus k squared is equal to r squared. We need the center for that with its coordinates h and k, and we need the radius. So let's plot what we have and take it from there. We have 2 endpoints of a diameter given. One is at -1, 5. 1, 2, 3, 4, 5. The other one is at -5. 1, 2, 3, 4, 5. -3. Here are our 2 endpoints. And between these 2 endpoints, we have our diameter. And we know that the center of our circle lies on this diameter. So let's find the midpoint of our diameter. Remember the midpoint formula. For the midpoint formula, we're averaging the x-coordinates. That means we're adding them and dividing by 2. And we're also averaging the y-coordinates. Divide them by 2. -1 plus -5 is -6 divided by 2. And that is -3. And 5 plus -3 divided by 2 is 2 divided by 2, and that's 1. So -3 and 1 are the coordinates of the center of our circle, And as I said before, maybe we could have eyeballed it, but it's better to be safe. Now, the next thing we need is our radius. And the radius is half of the diameter. It goes from the center to one of the points on the outside. And again, we can use the Pythagorean theorem if we have it nicely in our coordinate plane here. We have to go 2 to the right and 1, 2, 3, 4 up. So r squared is equal to 2 squared plus 4 squared, which is equal to 4 plus 16, or 20. And remember, we don't even need to know that the radius is actually the square root of 20, or even simplify the radical. All we need is our r squared for our equation, which goes x minus negative 3, so plus 3 squared, plus y minus 1 squared is equal to 20. Alright, you guys, well done. That's it for today, and I will see you in class.